Today we'll be using this guitar for today's experiment. Before we get started, let's give some background info. The area of physics that interests me the most are wavelengths. I also play a lot of string instruments as well, such as the guitar and the ukulele. So basically, one day I was playing around with my guitar, individually plucking strings, tapping on it, like random stuff that you do with the guitar, and I made an observation that some strings sound dull and some make an echoing noise once I tap on the frets. What are those echoey noises? What is a harmonic? Harmonics are additional frequencies that accompany the fundamental frequency of a signal or waveform. Harmonics are like extra notes that are present along the fundamental notes in a musical sound. They contribute to the overall tone and quality of the sound. Let's take a guitar string for example. When you pluck it, it vibrates not only at its fundamental frequency, but also at frequencies that are multiple of the fundamental. These higher frequency vibrations are the harmonics. The combination of the fundamental frequency and its harmonics give each sound its unique character and distinguishes it from other sounds. Standing waves and harmonics. Just a little reminder, harmonics are frequencies related to the fundamental frequency, which is basically the lowest frequency produced by a source like an instrument. From the strings on a guitar, it experiences repeated reflections at both ends of the string, resulting in a multitude of wave cycles traveling in both directions. And if this vibration is a particular frequency, it will produce an interference pattern that appears to be a completely stationary wave, which are called transverse standing waves. These waves can only have particular frequencies for a string of a given length because they can only have integer numbers of half wavelengths, since the waves must return to zero amplitude at both boundaries. One important thing to note is that the number of half waves is quantized, and these are the allowed values and the forbidden values. Standing waves contain node, point with zero amplitude, antinodes. Amplitude is at maximum. The string will be stationary at the nodes and other sections. If vibrating rapidly enough, it will appear to the human eye to create loops. More nodes mean more energy. Each harmonic has a specific wavelength obtained by dividing the fundamental frequency's wavelength by the harmonic number. Signals contain energy at harmonic frequencies, contributing to their overall waveform. The lowest and longest wavelength pattern produced by the guitar string is called the fundamental frequency, or the first harmonic. It only has one antinode between the nodes at the ends of the string. Let's say the fundamental frequency of a signal is represented by F. The harmonics of the signal are obtained by multiplying the fundamental frequency by whole numbers. So the second harmonic would have a frequency of 2F, the third would have a frequency of 3F, and so on. To understand harmonics better, let's also consider the wavelengths. The wavelengths represent the distance covered by one complete cycle of signal or wave in a specific medium. For the second harmonic, the wavelength would be W, so W divided by 2. And for the third harmonic, it would be W divided by 3. Here, W represents the wavelength of the fundamental frequency. In summary, understanding harmonics and wavelengths involve recognizing the relationships between harmonics and the fundamental frequency. Composers often use harmonics to add a shimmery, belt-like quality to music. So the purpose is to identify the locations of harmonics on an acoustic guitar and relate them to guitar string lengths. So for materials, we need an acoustic guitar, a tuner or tuning app, a ruler or measuring tape, some paper, and a pen or pencil. So when finding harmonics on an acoustic guitar, we would first have to select a string out of the 6 strings on a guitar, starting at the 12th fret. It is very tricky to try to play a harmonic. It took me a few tries to get it, but I couldn't really hear the harmonics happening since the strings on my guitar aren't the best quality. They're more on the cheaper side. So once you selected your string and you're on the 12th fret, you want to lightly damp that string above the 12th fret. If a harmonic is heard and you hear like a ringing bell tone, I marked that on my table. If our harmonic is not heard and the string sounds a little bit dead or dull once it is plucked, I did not write that on my little table. Now I would do the same thing on the same string from the 12th fret to the 1st fret. And I would repeat the first 2 steps for 2 more additional strings. For the steps, number 1, I had to measure the length of one string from the nut to the bridge with a tape measure. Basically all the strings are the same length on a guitar, so it doesn't really matter which string I chose. And number 2, I made a data table for each string tested. Number 3, I would measure the distance from the nut to the fret where each harmonic was heard with a tape measure and record this value in the second column of my data table. Number 4, I would calculate the fraction of the total string length by dividing the distance from the nut to the fret by the string length, and I would enter my calculation on the third column. Number 5, I would obtain the reciprocal of the fraction and put that on a fourth column of the data table. And number 7, I would figure out the closest whole number to the reciprocal to obtain the harmonic number. I've noticed from each string that I use, I've gained the same results. Doing further research after this experiment, there is a chart where natural harmonics reside. When looking back at my table and the chart, I can confirm that my data is right. There are many things that I would like to change with my experiment though. I feel like I should have used a guitar pick instead of using my fingers. That would make the sound more even and easier for me to pluck the strings. I also should have used a metronome to make sure I am plucking each string at an equal rate. If I would do this experiment again, I would get better strings due to my cheap strings on my guitar. The harmonics would have sounded more clearer. It would have been easier for me to distinguish which are harmonics and which are not. Although this topic really messed with my brain and music theory really made me want to die on the inside, gain more knowledge about waves and how they affect the sound of music.